All right. Some of you are probably like, where do I go right now in my notes? Because I don't see any place. There's no other notes. I did not plan on doing this unit, this topic today until midway through this unit. I thought we need a day of proofs, definitely. All right, if I'm going to throw one on quiz 3, we need a day of proofs practice. So you guys can go to page 58 in your packet. The 3 proofs we're going to do in class are in your packet, starting on page 58, number 29. So that's where you can go right now, page 58, number 29. There's 3 proofs, 29, 30, and 31. We're going to do all 3 of them in class. Hold on, homework. Homework will be posted on Google Classroom for everybody. All right, I'm not going to post it anywhere else. I'm not going to print it out. If you guys want to do it in Canny, fine. If you want to copy it down onto loose leaf and take a picture of it for me on Monday, fine. Whatever gets the job done. But everyone's going to have access to it on Google Classroom under assignments. Okay? I will put that on as we work today. All right, I'll put that assignment on as we work. But everyone, no matter if you're virtual, in class, remote on Monday, everyone gets the assignment under assignments on Google Classroom. All right? Okay, here we go. 29. We are going to have a proof on the quiz next week, and it will, anything goes. Anything. Any theorem from day 1 on goes. Fair game. Okay? That's why I felt the need to do this day, because this unit started a month ago. I believe it was March 20-something, a month ago. So some of these theorems are completely out of your mind, and I want to reintroduce them to you. Starting with problem number 29, I am asking you to prove those 2 triangles congruent. I don't have time to ask you guys, but here you go. Side, 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 angle, side, angle, side, angle, 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 side, and possibly, if it's a right triangle, possibly it might be H up. So those are my 4 methods. They tell me 2 lines are perpendicular, and they already placed the right angles in there for me. I don't know if that's going to do me any good with the triangles, and I'm also told OE is congruent to OF. So maybe they told me that for a reason. I don't know. All right. So I have 2 triangles congruent. We have now finished 30 weeks of math in here, geometry. You can use anything you want from those 30 weeks. Don't think it's got to be just circles, circles, circles. You can use any theorem we have used from all the 30 weeks here. So if I'm going to start by getting those triangles congruent, do you see a circle fact or a fact from earlier on in the year I could use here? Omni, please start.
AD is congruent to AD using the reflex.
There we go. Let's throw that out there. That's good for everyone, I hope. AD congruent to itself, reflexive. Point D is, yes, that's supposed to be on the circle, all those intersections. Done. I got a side down. All right, we need more then. We need more, right? Go ahead, Quincy, what do you got?
AB is congruent to AC.
Good. AB congruent to AC. Now, here's why I'm doing this day. A lot of you, I think most of you would say, okay, I know they're congruent, but what the heck do I write? All right, which I agree. That's why we're doing this day, and I don't want you to be nervous come quiz day next week. AB congruent to AC. AB is a tangent. AC is a tangent. If they're drawn to the same external point, they're congruent. 2 tangent segments drawn to the same external point are congruent. And yes, these are wordy, so that's why I'm reviewing them all with you today. 2 tangents drawn to the same external point are congruent. If you want to write tangent segments, I'm fine with that too. I'm not going to be picky with that. Are congruent. All right, another pair of sides. Done. I know it's been a few days since we've done a proof, but the givens are provided for a reason. Why in the world did they give us OE congruent to OF? All right, why? Why did they do that? Go ahead, Maeve, take it.
Because chords equidistant from the center are congruent.
There you go. So that's what we're doing. That.
these.
Yep, got it. That right here, knowing OE is congruent to OF, leads us to chord DB being congruent to chord DC. And that theorem is just what Maeve stated, which is chords equidistant from the center are congruent. Okay, chords equidistant from the center are congruent. And there it is, right? There's our third pair of sides. And we're good to go. Triangle ABD congruent to triangle ACD. Side, side, side. All right. Yep.
You don't necessarily use everything at first, but we never use the perpendicular lines. Is that supposed to be used for something else?
Well, they give you the perpendicular lines just to show you that, because the only way that they can be equidistant from the center is the perpendicular distance. That's why.
Oh,
So you have to draw it. They have to be like I can't do this and put that there. Those aren't equal. Oh, that line I just drew, and OE wouldn't be equidistant. All right, we ensure that they're equidistant because they're both perpendicular to it. Okay, so that's why they gave it to you.
they are.
Okay.
Oh, never mind. Sorry.
Okay. All right, last thing here. Before I leave this proof, let's say in the givens, I did not ask you to prove the triangles congruent. Let's say I asked you to prove these two angles right here congruent, BAD and DAC. What's my next step then? I would do exactly what I just did with you guys, but what would be my next step then? Those two angles are congruent because of? Atticus? CPCTC. So I just want you guys to keep that in mind. I'm not stopping at triangles being congruent. I want to continue on. What else could I have done? All right, and yes, I could have proved any corresponding parts congruent by CPCTC. Questions here before we go to the next? All right, so you proved triangles congruent. How about give me a pair of triangles similar now? I want to go all across the board what we've done this year. Let's prove triangles similar in number 30. Before we start, what's going to be my only method in a proof to prove two triangles similar?
Angle.
Angle. There's two other ways, side, angle, side, and side, side, side. But when it comes to a proof, the only method we really have available is angle, angle. So here's what we need to do. Two pairs of angles congruent. Where are they? That's what we need to do. Where are those two pairs? Please make sure, I'll get back to you guys in 1 second. Please make sure you notice what two triangles we're proving similar. All right, because you guys see two triangles, the two smaller ones, but those aren't the ones we're proving similar. It's the big dog and one little one. All right, so we got ADC, this big one here. Going to try to prove it similar to DBC. All right, so I need two pairs of congruent angles. Maeve, go ahead. You wanted to speak up?
Yeah, I was gonna say, can I do number 2? Yeah. Okay.
Oh, just tell me something about the diagram. Go ahead.
Tangent AD is perpendicular to diameter CP.
That's correct. Everyone see that? Yep, you're good. AD is perpendicular to DC. Now the question is, how did Maeve know that? Because she used a theorem from this unit. She mentioned diameter. I'm going to shorten it a little bit. What's OD? That's a radius. And what was AD again? And when they meet, forms a right angle. But that's not what the theorem says. The theorem says they're perpendicular. So that's important that Maeve told us that they're perpendicular. Because if you put in that they're a right angle, that's not what the theorem says. The theorem says the two are perpendicular. So a radius And again, they're wordy, so that's why I'm reviewing it. A radius drawn to where? What's point D called? What do we call point D in this unit? What's the vocabulary term?
Point of tangent.
There you go. Radius drawn to the point of tangency is perpendicular to the tangent. All right, now what happens? If those two are perpendicular, what usually happens? You got a right angle. Yep, so angle ADC is a right angle. And that's just perpendicular lines form right angles. So I got a right angle at ADC. Now, in your mind right now, you should be started thinking, wait, if it's angle, I just put a right angle down. That means in the smaller triangle, I should have a right angle somewhere there so I can put them congruent, right? Now, just by looks, let's be honest, you could probably tell me it's going to be DBC. But can you tell me why? How do I know that other than just by looks? I don't think that's a good reason to write in, right? Just by looks, why that's a right angle. It is a circle theorem we've gone over, sorry. Why is that going to be a right angle? Think about what type of angle it is. And look where it's drawn. Anthony, what do you got?
An inscribed angle formed to a semicircle is 90 degrees.
Okay, it's inscribed. It's inscribed and it's drawn to a semicircle. If you want to use the word diameter instead of semicircle, that's fine. So an inscribed angle drawn to a semicircle or diameter is a right angle. Yep. Now you can tell me the right angles are congruent. And that's your first A in angle. All right angles are congruent. There's one A. What's the deal with the other pair of angles? Somewhere there. Oh, look at this. Boom, boom. Just lightening up the room. Hannah, what do you got?
Angle C is congruent to angle C.
Everyone agree? Angle C. Full angle in both triangles. There you go. There was my missing A. Angles can be reflexive. Angle C, congruent to angle C, reflexive. ADC, DBC. Okay, everyone stop. Don't go on to the next proof yet. I want you to be ready for everything. Okay, good job. You proved the triangle's similar. Let me change the proof statement now. You've done all this beautiful work. You proved the triangle's similar. What if in the proof statement I ask for this? Why is AD over DB equal to DC over BC? What if I put that in the proof statement? Similar triangles. You proved the triangle's similar. Now why are their sides in proportion there? Sophia? You're one ahead of me. You're one reason ahead.
I don't know.
Corresponding sides of similar triangles are proportional. CSSTP. If I asked you to prove the sides are in proportion, I would prove the triangles similar, then show by CSSTP they're in the same ratio. Now, what if I put this in the proof statement? AD times BC equals DB times DC. Now you would tell me product of the means equals product of the extremes. I'm doing this with you. So number one, you don't get freaked out on tonight's homework, maybe the quiz. You see this in the proof statement. Oh, it's a similar triangles proof. Angle, angle, CSSTP, and then I'm going to end it with means and extremes. All right, so I don't want you to get freaked out if you see that. We've never done. Yes, we have. I just wanted to remind you, it's part of a similar triangle proof. All right, good. So we did congruent triangles. We did similar triangles. Any questions? All right, I am leaving this one up to you for a while. Okay, up to you guys. I'm going to give you a lot of time to just sit there, think about how we would do this. I'll start you off. Look at what we're trying to prove. Line segment BE and line segment CE are congruent. Only way we're doing that is what? Proving the triangles. And there's only one pair of triangles that contain both. BE and CE as full sides. So first decide what two triangles those are. What two triangles contain BE and CE as full sides? Are we all agreeing that it's EBA and ECD? Those are the only two triangles that have BE as a full side and CE as a full side. And in the givens, really the biggest given that was provided was chord BC and diameter AD are parallel for a reason. All right, I'm going to let you guys work. How can you get those triangles congruent so you can say CPCTC? And this is the closest we can come to group work in here. If you guys want to turn around, work, talk it out with somebody next to you, feel free. All right, you guys that are in class, all right? If you get stuck, hey, what angles, what sides did you get here? What sides, what angles? I'm going to give you guys plenty of time here because this is our last one. And everyone's got their packet in front of them right now, or a digital copy. Look back if you forget a theorem. You think they're congruent, but you want to know why.
So I wrote comments, something that I think is relevant to this at home. Do you mind if I look something up?
Whatever you need to do. All right, guys, let's talk. Let's talk here. By the way, as I go over this, there are different versions that I'll speak about as we finish this. I'm going to say most of you just hit up the good old verts first, right? Vertical angles congruent. So I have angle BEA congruent to angle CED. Vertical angles are congruent. Okay, there's my first pair of angles down. Okay, next up, let's talk. Why did they give me the chord and the diameter parallel? This is something I didn't teach in class. It was an ed puzzle. It was part of I did teach it, but on video. It was part of an ed puzzle video. When two chords are parallel, what happens? No, not the chords.
If they're drawn to parallel lines.
Not chords aren't congruent. There's something else that's congruent.
No. Oh.
Not the chords. The arcs are congruent, okay? If two chords are parallel, the arcs in between are congruent. So we can now say arc BA congruent to arc CD. I guess we could go implies. Two parallel chords, and again, I'm pretty flexible with the wording as long as you get the point across. Two parallel chords imply arcs in between are congruent. Okay, two parallel chords imply the arcs in between are congruent. All right, now, Ami?
Would parallel chords intersect congruent arcs also?
Perfect. I like it a lot. Now that the arcs are congruent, we definitely went over this theorem a lot. Now the arcs are congruent, so are the Ooh.
Chords.
Yep, the chords that make them. So not only are arc BA and arc CD congruent, but so are chord BA and chord CD. Congruent arcs imply congruent chords. Anybody take a look? There's a pair of sides now.
I have a question.
Yeah, man, go ahead.
How come you can't just say BA and like chord BA and CD? Like, because they're always going to be congruent. So like, why can't you just say that?
Why can't you say parallel chords? I mean, parallel chords. And well, here's the thing. Like, how are we gonna? If the chords are parallel, what do we say is congruent?
I would say that like the art like are you talking about like just words in general?
Yeah. See, what I'm saying is, if you give me BC and AD parallel, fine. What would be your wording to say, okay, BA and CD are equal? You see what I mean? Like, I'm getting there because the arcs are congruent. I don't know how we would phrase. Maybe it is a theorem. I'm not aware of it, but I just don't know how I would word that in the reason that if those two chords are parallel, why the other two are congruent. Okay? Because here's the other thing, maybe I don't draw in, maybe I do a proof where BA and chord CD aren't even there. Okay, but I need to know that the arcs are congruent to say the inscribed angles are congruent. Okay, so knowing the arcs are congruent is pretty powerful. I see what you're saying, but it may not be every time that I draw in chord BA and CD, or maybe I don't even need it. That is probably where I think many of you got to. I think the hardest part is what's left now. What about the other pair of something I need, right? Because you guys still owe me a pair of sides or angles to get these triangles congruent. And this third pair could have came in many different versions. Quincy?
Angle ABD is congruent to angle ACD.
Okay. Okay. One thing you could have said, and here's what Quincy just said in class. Angle ABE, this top one here, is congruent to angle ECD, this top one. Inscribed angles drawn to the same arc are congruent. Maybe you didn't want to use those two. Take a look, everybody. Maybe instead you use angle BAE congruent to angle CDE. Same reason. Two inscribed angles drawn to the same arc are congruent. How many of you went really hardcore and told me angle ABE was a right angle and angle DCE was a right angle because they're inscribed angles drawn to a semicircle, then said the right angles were congruent? All different versions. Yes?
I tried saying alternate exterior angles, so that not work because it's not.
Where are the alternate exterior? Okay, here are, let me get rid of everything here. Here are my parallel lines. Okay, now tell me what your transversal is that you're using alternate exterior. Because exterior tells me they're on the outside of the parallel lines. And if those are my parallel lines, outside is here and here. There's alternate interior angles in this diagram, but I don't know where the alternate exterior are. Okay? And I just, by erasing that, I did there we go. All right, so I'm just going to go with Quincy, what he gave. What did you give me, Quincy, again? ABE or ABAE? Okay, so I'll go with those. So angle ABE congruent to angle DCE. Inscribed angles drawn to the same arc are congruent. And then there you go. Now I can say triangle ABE congruent to triangle DCE. What method, by the way? Angle side, yep. And then CPCTC. It's about as tough as they come here. And really the only reason they're tough is because those circle facts aren't in your mind all the time. Other questions from you guys? Tonight's homework has already been posted to Classroom for everybody. There is no answer key, and I will not put one on Classroom because I want to see what you can do on your own tonight and over the weekend. Monday, we'll go over those proofs, go over what's on the quiz, practice a couple questions, and then Tuesday, Wednesday is the quiz. All right, be smart, be safe this weekend. I'll see you guys on Monday. Quiz.
It's gonna be all the whole certificate.
I have a quick question.
Yep. Go ahead, Kyla.
For number 3 on the proof that we just did,
Yep.
instead of saying that, like, since they're parallel, you can figure out the line, and you can figure out the arcs, could you also say that the arcs are congruent because the angles are congruent?
What angles?
BEA and CED.
But they're not central.
Oh, okay.
For that to be true, those angles would have to be a central angle.
Okay,
Okay? Yep.
thank you.
You're welcome. All the theorems we've gone over are fair game because we're having a proof.
Okay.
But it'll be circle equations, measures of chords, segment times segment, measures of tangents and secants, which is whole times external, and the proof. So all theorems are fair game here, specifically for the proof. Oh, and remember, I'm putting another multi-part circle question on there with the angles. So I don't want to.